So as we know now, there is this concept of global monsoon, and of course just monsoon typically refers to the Indian monsoon, but there are strong monsoonal circulations around the Indian Ocean, East Africa, India, Indonesia and Australia, and of course East Asian monsoon. And there is a very strong West African monsoon as well, and now we also have North American monsoon, South American monsoon, and so on. In the context of the Holocene, I think it's worth looking at the Indian Ocean monsoons, including the West African monsoon, which of course is much more affected by the Atlantic and the ITCZ in general. So the global monsoon, if you've been following that literature, essentially looks at annual cycle of rainfall. So if summer rainfall is more than 60% of the annual total, they call it the monsoon, call it a monsoon, and you can see that it basically corresponds to the ITCZ. In terms of where we want to go in the Holocene, we have to remind ourselves that all monsoons are locally affected by various land, atmosphere, ocean interactions. So here Gulf of Guinea tends to be warm, even though there are trade winds and upwelling closer to the equator. So there are local factors like vegetation and ocean and land use that matter, and then there are remote forcing like El Niños and their interactions with the Asian monsoon, again through the so-called monsoon desert mechanisms, which I won't go into, but there are also easterly jets coming from the monsoon region over the Indian Ocean into Western Africa and so on. So there are issues of dust which also affect the monsoon dynamics directly through solar dimming and so on low frequencies, also at high frequencies by affecting cloud microphysics. So there are direct and indirect impacts of dust and so on, and of course lakes, especially now with irrigation in some regions of India, for example, local sources of moisture can be important in terms of the progression of monsoons during the season. And there is also a relation now between what's happening in the Arctic and how maybe the jet stream is responding to that, or Arctic sea ice loss is affecting Rossby wave trains coming down into lower latitudes. So all these things are now interacting. Looking at African monsoon, obviously the African greening of Africa or the African humid periods have gotten a lot of attention, especially since one of them happened during the Holocene, and now it is a desert. Sahara and Sub-Saharan Africa remains kind of a poster child for a lot of climate issues, human interactions, vegetation, grazing, agriculture, land use, etc., and climate change. So the context for the greening, though, is there in the longer term climate variability as well. So Earth precessional cycles and African humid periods, we will look at the figure in the next slide. We look at time series of Earth's precessional cycle, which we can compute very well, Milankovitch cycles in the red, and radiative forcing of CO2 changes associated with these because of glacial deglacial cycles, and the drawdown of CO2 or drop in CO2 during a glacial and release during the interglacial. The arrows indicate the impact of changes in precession values on the northern hemisphere summer insolation. So let's look at that here. Here's the radiative forcing of CO2, additional energy trapped when CO2 goes up and the other way. So precession is shown here in terms of the red curve with modulations by eccentricity cycle. So the 100,000 year eccentricity cycle and the 19 to 26 year 26,000 years precession cycles tend to combine to produce this modulated time scale. So when we are in this phase here with warm CO2 forcing we are in the decreased northern hemisphere summer radiation and desert Sahara, whereas green Sahara occurs with increased northern hemisphere summer solar radiation. Okay, so there is a drop in the CO2 forcing because warm periods would correspond to decreased ice cover. Okay, so you can see that the time scale of CO2 is obviously very different than the precession time scale, because we know that the orbital forcing, typically radiative forcing at something like 65 north, can trigger the onset or retreat of glacial cycles with positive feedback in ice albedo, but the internal feedbacks produce multiple time scales. I can feel the cleaning person coming in and will probably ring the doorbell soon, but in the meantime, looking here at the barium aluminum evidence of observed state, we have reversed here the axis. Here green Sahara was here and desert Sahara was there, whereas we are green Sahara here and desert Sahara here. So this is paleoclimate data based on the barium to aluminum ratio at ocean drilling program site 968 in the eastern Mediterranean, which is closely related to the dynamics. In fact, greening of Sahara is argued to require winter precipitation over the Mediterranean. So it's not just what happened locally, but presumably also how the Mediterranean was responding. Of course, they are closely connected through the ITCZ moving back and forth, but there is also high latitude dynamics in terms of the jet stream, as we will see in a minute. Okay, which is a proxy for the wet and dry Saharas. Periods in northern Africa during the last 230,000 years is what we will look at. The green and blue lines represent the sapropel start and end dates respectively of each green Sahara period during the last two glacial cycles. Sapropel is basically organic matter that gets deposited, and if there is high rainfall and high river runoff, then it doesn't get consumed or respired, so it gets accumulated, and during the dry period it accumulates less. So there was the bell. So let's continue with this story. During the last 230,000 years, the green and blue lines here represent the sapropel start and end dates respectively of each green Sahara period during the last two glacial cycles. The arrows indicate the directions toward vegetated and desert Sahara. Okay, so that's just these lines here. So you can see when green Sahara happens, sapropel accumulation increases. When drying happens, then it ends. So you have multiple green periods during these 230,000 year cycle. And if we come close to our MIS stages that we have been looking at, you can see that there is a long hiatus where the greening didn't happen. The glacial period here basically made Sahara dry for an extended period of many thousand years, and then as we came out of the last glacial, we had one burst of greening of Sahara, which then disappeared again. Okay, so this shows the East African monsoon in this context. So there is the Indian summer monsoon, West African monsoon, and the ITCZ, and the other front here at the June, July, August time frame, which is very important. So this is the map of the Northeast Africa with the positions of terrestrial and marine archives mentioned in the text. The black box denotes Lake Dende region, approximate locations of the intertropical convergence zone, and the Congo air boundary during the northern hemisphere summer are shown. Okay, so let's just look at some data over the Holocene period. So here is the precession again, the June, July, August insolation in watts per meter squared at 10 north. Obviously we came out of the glaciation with high summer forcing, which dropped off, and you can see the variation of the Indian Ocean region here seen in concave. So this corresponds to precipitation levels in these multiple proxies, with high precipitation here and low precipitation in this direction. So high precipitation, and then we'll look at Indian monsoon in more detail and the civilizations there. This is the Levantine Sea barium calcium proxy showing East African monsoon also peaking and dropping off. So this is the Nile River runoff showing strong runoff during wet periods and weak runoff during dry periods. And then you have West African rainfall here showing this is Nile River runoff, this is East African precipitation, and this is West African. So there is a coherence when you compare these different regions. Obviously the vertical gray bars mark the abrupt changes in the monsoon system based on different proxies. So we can always argue about what is abrupt change, but various indices can be used, but generally it's something you can see in archaeological evidences and soil stratigraphies, ocean sediments, and so on. Finally, here we are looking at the same thing, but now adding a little bit of details here in terms of the Nile Valley Egypt settlements. So occupation happens during wet periods, but when transition happens with abrupt climate change, abandonment happens, and then reoccupation happened here. So you can see that the relations with rainfalls are not that immediate and not that direct. So this again raises the issue of collapse. So trend and pace of changes in proxy time series for East African, West African, and Indian Ocean monsoon hydroclimates. Archaeological based estimate of time windows of prehistoric human occupation and abandonment of riverbank settlements in the Nile Valley. In B, we are looking at estimated Nile River runoff, which we already mentioned, considering analytical and time series uncertainties. So there is a modeling exercise involved here. Orbitally force changes in insolation. Okay, and D is delta 018 time series analyzed in stalagmite from Oman, indicating changes in Indian monsoon. There are some details there in terms of interpreting Indian monsoon versus African monsoons and what it is saying in terms of stalagmites from Oman caves and so on. Okay, finally the Holocene evolution of West African monsoon inferred from barium calcium analyzed in Globigerina ruber pink from sediment sequence retrieved off larger river systems draining the West African monsoon area. Okay, gray areas and horizontal arrows indicate gradual rise and decline of the Nile River runoff. Okay, so rise and decline happens over time, and reoccupation depending on how extensive the settlement became and how much they were invested in agriculture and population centers. The decline of civilizations can be slower with innovations on water saving and so on. So again, just indicating that collapse is not always abrupt, even though climate change may in fact be abrupt. Okay, I'll come back and look at the East Asian monsoon and then the Indian monsoon. Okay.